In lesson 1.3, we're working with linear inequalities now. The same rules as working with equalities apply. We still have the multiplication principle and the addition principle. And again, we're looking for values which make these algebraic expressions true. Okay, so let's start with this example. 14 minus 5y is less than or equal to 8y minus 8. Let's go ahead and add 8 plus 8 to both sides. We end up with, we add plus 8 to both sides. Minus 8 plus 8 makes that vanish. And 14 plus 8 is 22. So we're left with 22 minus 5y is less than or equal to 8y. This is already simpler. So we're gonna make it even simpler by adding 5y to both sides. 22 minus 5y plus 5y is less than or equal to 8y plus 5y. Let's go ahead and simplify that. Minus 5y plus 5y, that vanishes on this side, but 8y plus 5y is 13y. So 22 is less than or equal to 13y. Now let's multiply both sides by the reciprocal of 13. So 22 times 1/13 is less than or equal to 13y times 1/13. Now the reciprocal of 13 is 1/13, so multiplying them together gives you 1. 13 times 1/13 is y, is just y. Over here, 22 times 13 is 22/13 is less than or equal to y. Okay, so any value that you put in for y that's greater than 22/13 is going to make this expression true. Now we have some notation here that we can express that in. Y, such that y is less than or equal to, or excuse me, y such that y is greater than or equal to 22/13. Notice that we reversed the order here, so we have to reverse the sign as well. And that is set builder notation. And then we have an interval here. Okay, so or, and this is a square bracket, meaning that the point 22/13 is included. So 22/13 will make this expression true all the way up to positive infinity. And then, of course, positive infinity, we put a regular curved parenthesis right there. So the two choices on your set notation are the square bracket, meaning the point right here is included, and the curved bracket, meaning that it is excluded. Okay, in other words, all the way up to infinity, but we can't plug infinity in for y, because that's not something we can calculate. Okay, the second example, 3x minus 3 plus 2x is greater than or equal to 1 minus 7x minus 9. All right, so what are we going to do to make this simpler? Let's rearrange it a little bit to combine some terms, and it'll look a little more familiar afterwards. So over here on the left-hand side, we have 3x plus 2x, so 3x plus 2x, and then we're left with minus 3. And then over here, I'm going to rearrange this so this is 1 minus 9 minus 7x. That's exactly what we have here. We'll evaluate the 1 minus the 9 and the 3x plus 2x. Over here we get 5x minus 3. And on the right-hand side we get minus 8, or 1 minus 9 is minus 8, minus 7x. All right. So let's go ahead and add 3 to both sides, positive 3 to both sides. If we do that, we get rid of the minus 3 on the left-hand side, and we add a positive 3 to the right-hand side. And so minus 8 plus 3, it's going to be minus 5. So we have 5x is greater than or equal to minus 5 minus 7x. And then we can move the x over to the other side, all of the terms involving the x over to the other side, by adding 7x to both sides. So 5x plus 7x is greater than or equal to minus 5 minus 7x plus 7x minus 7x plus 7x. Again, that goes away. And we end up with 12x is greater than or equal to minus 5. Well, then we use the multiplication principle, which I didn't show explicitly. And we're going to multiply through by the reciprocal of 12. So 12 times its reciprocal, 1/12, is going to be equal to 1. So the x will be left by itself with a coefficient of 1. It's going to be greater than or equal to 1/5. And in the end, we're going to multiply that by 1/12. So we end up with x is greater than or equal to minus 5/12. Any value that we put in to that original expression that's greater than minus 5/12 will give us a true statement. Okay? The way we can write this in set builder notation is we use the curly braces, x such that x is greater than or equal to minus 5/12, or in the, you can specify the interval with a square bracket. Remember, we're using greater than or equal to, so the minus 5/12 is included in the interval, so minus 5/12 with the square bracket all the way up to positive infinity. Okay, hope that was helpful. If you have questions, please specify the timestamp. For instance, hey, I have a question about the step that you did on 4 minutes and 20 seconds, and then I can go to 4 minutes and 20 seconds and I can see what that step was and see if I can give you some additional information. Okay, good luck on the rest of your assignment.